Salam Joano. So we're doing 5054 October November 23 ATP paper planning question. You're investigating the average speed of a trolley which is moving along a horizontal bench, and they've mentioned the what trial are they conducting. They want to see the relationship between the average speed and the mass of the trolley, which is why if you notice they've given you sets of masses, so you can keep on adding mass and they will notice what is the stopping distance, how does it change with the mass. Now they've made it very, very clear that stopping distance is the distance moved by the trolley from the bottom of the ramp till it comes to a stop. So let's say it stops here, then when you change the mass, maybe it stops here, then when you change the mass, maybe it stops here. And you have to calculate the average speed of the trolley along the bench until it comes to rest. So you have to measure the time and you have to measure the distance, and you have to add masses so that the stopping distance changes. Now, whenever you're doing this question, I always tell that the first thing you do is you define your variables, which is what is your dependent variable, and control variable. Your independent variable will be the mass that you place in the trolley, because that's what you're going to change. Dependent variable will be the average speed of the trolley or the distance moved by the trolley. You can say average speed because that's the question. Control variable is something which you should keep constant, otherwise the stopping distance could change, and for us that could possibly be the height of the ramp, or the point from where let's say your trolley is, this is the ramp, your trolley should be at the same point every single time you do the experiment, because if you change the position, then the stopping distance would change without you changing the mass, and we don't want that, because we want to change the mass and then we should notice what is the difference in the stopping distance. So control variable is very important to identify. Now, how do you perform the experiment? For each trial, which means for each reading, you change the mass and note the time taken for the trolley to come to rest. And remember that this is going to be in the horizontal part, because that is the distance that we're measuring. The time taken is measured using a stopwatch. Stopping distance is measured using measuring tape. You could even say meter rule. And then they ask you to make a table. So basically, you're just answering these questions. Explain briefly how to carry the investigation. You just explain any apparatus, any new apparatus we've already mentioned. We're using a stopwatch and we're measuring. We're using a measuring tape. Variables to be kept constant, what you do at the very start. Draw a table with column headings to show how you will display your readings. So your independent variable, your dependent variable, and then your whatever you want to calculate. So mass, stopping distance, time, and finally average speed. And if you know the units, that's even better. You can put the units with them. I've written stopping distance in centimeters because you know that you can't travel distance in meters. It's a lab based experiment. You're not doing it on the motorway. Then finally, they always ask, how do you reach conclusions? And there's a standard answer for that, and that is a graph will be plotted with the average speed, your dependent variable and your independent variable. So a graph will be plotted with the average speed versus mass. Remember, what I said was generic. That is for you to remember that a graph has to be plotted of y-axis versus x-axis, which is dependent variable and independent variable. So mass is independent, so mass is here, and average speed will be here. And the trend of the graph will determine the relationship between the two variables, and that's pretty much it. Yes, if they did ask you, let's say it's a different question, and they ask you to add any safety or any additional detail, you could say that you should probably place a cushion so that if the trolley falls, it does not fall on your foot. That's additional detail or safety, but that depends on question to question. All right, another question for investigation. A student investigates the time taken for ice cubes to melt. This is May-June 23, 5054, paper 4.2. So basically you have ice cubes, you will put them in hot water and you will surround the beaker with cardboard. And they've told you that you have cardboard sheets of 2 mm and you've got a supply of them, which means you've got many of them. You've got hot water, you've got a supply of ice cubes, thermometer, stopwatch, and the beaker. How are you going to carry the investigation to show how the thickness around the measuring cylinder will affect the time taken for the ice cubes in the beaker to melt. That is the goal of this investigation. So again, I've just made a diagram, although they didn't ask you to, just to give you an idea that this is the beaker in red, and this is the cardboard which is surrounding it, and you put the hot water in it, and the ice cubes are floating. Thermometer is used to measure the initial temperature of water, because it's important that every single time you put hot water has to be at the same initial temperature, because if the temperature of hot water changes, then naturally the time taken for the ice cubes to melt will also vary, not because of the cardboard, but because the water was not hot enough. So the independent variable will be the thickness of the cardboard, which is our investigation, that we will keep on increasing the layers of cardboard around to increase the insulation, and then we'll see how the time taken to melt changes. And the control variable will be the initial temperature of hot water and the amount of water. You could mention any one of them. The amount of water is also important. Now, the beaker is wrapped. What is the process? Beaker is wrapped with cardboard of known thickness. The thickness is measured using vernier caliper, although they've already mentioned that it's 2 millimeters, but it's still good practice to measure it yourself once. Hot water is added and ice cubes are added at the same time. The initial temperature of the water is noted using the thermometer. Stopwatch is used to measure the time taken to melt the ice cubes. Now you repeat the experiment for different thicknesses of the cardboard, and you have to mention that you keep adding layers. Then you have to put a table, tabulate your results. So you have got thickness that you're changing and the time to melt, which will change because of changing the thickness. And finally, how will you reach your conclusion? A graph is plotted of thickness of the cardboard versus time to melt. The trend of the graph shows the relationship. I hope this makes sense.